So I'm Shadnoush, and I have been graduated from Concordia University in civil engineering. For my thesis, I worked on greenhouse gas emissions, and the name of my project is the assessment of urban greenhouse gas emissions from Montreal Island as a case study. Let's say there is an increasing concern about climate change that is resulted from greenhouse gas emissions, and there are frequent extreme weather like flooding, drought, and wildfire that we have recently experienced in California, unfortunately. So that's why there are many governments that they are committed to reduce their greenhouse gas emissions. For example, for federal government, Canada, they are committed to reduce 40% of greenhouse gas emissions, and also Quebec is committed to reduce 20% greenhouse gas emissions below 1990 levels by 2030, and also Montreal should reduce 30% greenhouse gas emissions by 2020, and unfortunately, they haven't achieved these goals yet. So uh, the first step of reduction planning is the assessment of greenhouse gas emissions to figure out what are the main sources of greenhouse gas emissions. We need to go deeper on our way, we may find urban greenhouse gas emissions as the main sources of global greenhouse gas emissions. International Energy Agency in 2008 reported that although only approximate half of Earth's population lived in urban areas, over 70% of global greenhouse gas emissions are produced in urban areas. So that's why we may go for urban greenhouse gas emissions to figure out what are the contributing factors in such areas. So there are some questions that need to be addressed, like what is the relation among different urban emission sources, and also the specific question which is raised up by city councils is that with a limited budget, how we can maximize the reduction planning. So what are the contributing factors of urban greenhouse gas emissions? The challenges that in my work, there are a lot of previous studies that they are worked on provincial greenhouse gas emissions and greenhouse gas emissions from countries or global greenhouse gas emissions, but there is a lack of greenhouse gas inventories for urban areas about interaction of emission assessment factors. The objective of my work is to develop a model for the analysis of urban greenhouse gas emissions, assess the greenhouse gas emissions of Montreal Island as a case study of urban area, and analyze the sensitivity of model parameters, because in the previous works, there is no sensitivity analysis for assessment of urban greenhouse gas emissions, and they lead us to provide a science-based support for assessment of urban greenhouse gas emissions as the first step of reduction planning. And in my work, I try to make the assessment of urban greenhouse gas emissions, make it easier and faster and we can go quickly for reduction planning. So now I'm going to show you the methodology. Here in this slide, you can see the urban greenhouse gas emissions and the contributing factors. So we do have transportation. To make it more clear, I divide transportation into three sectors: public transportation, including buses and subways; suburban public transportation, that includes any trains that they connect urban areas to the suburb, and also private vehicles. For waste also, we do have two categories: wastewater and solid waste disposal. Electricity and heating are the other contributing factors of urban greenhouse gas emissions. Here, for the total emission, you can see the all contributing factors that we have already reviewed in the previous slide. For example, for EUPT stands for the greenhouse gas emissions from urban public transportation. ESPT stands for greenhouse gas emissions from suburban public transportation, private vehicles, heating, electricity, solid waste disposal, and at the end, we do have emissions from wastewater treatment. These are the details of the methodology that I have developed. The methodology that I have developed in each sector, I try to add more factors to make it more accurate results. So for example, for here, emission from urban public transportation as the first methodology that we are going to review. We do have amount of energy which is consumed by urban public transportation is multiplied by the emission factor. Emission from suburban public transportation, we do have three factors: average weight of trains, total travel distance. At the end is multiplied by the emission factor. So the weight of trains is actually affects the total greenhouse gas emissions that we're going to get from suburban public transportation. For emission from private vehicles, this methodology is based on the number of vehicles. So I add more factors to this methodology to get more accurate results. For example, we do have number of vehicles, and which is multiplied by the average travel distance by each type of vehicle. And the most important factor which I do added in my methodology is fuel economy, which is the amount of fuel consumed per each kilometer. For example, each different vehicles, they do have different fuel economy. For example, some hybrid cars, they definitely have the different fuel economy in when we compare with gasoline cars. So at the bottom of this slide, you can see the emission from fuel-based heating, that the total amount of heating fuel is multiplied by the emission factors. And for emission from electricity, I also consider the ratio of electricity generation, because in different urban areas, electricity is generated by different sources of fuels. So that's why I consider this factor to figure out the amount of greenhouse gas emissions which is produced by different source of fuel that they generate electricity. Here, emission from solid waste disposal, we do have many factors as you can see here, but it's based on the total amount of municipal solid waste. We do have degradable organic carbon, fraction of degradable organic carbon, methane correction factor, fraction of methane in landfill gas, and so on. So for emission from wastewater treatment, in most studies, they only consider methane. In most studies, they didn't consider nitrous oxide. Is that the lack of data? It's nitrous oxide with only adding one factor that makes it easy of urban greenhouse gas emissions. So for the results and discussion, is the boundary which has been considered as Montreal Island with the Ville de Montréal and also Énergir and Hydro-Québec. They really helped me to get the information, because even now I'm working for industry, and we do have some difficulties for assessment of urban greenhouse gas emissions. The most important thing that I'm going to mention now is that mentioned before, I try to make the assessment of urban greenhouse gas emissions easier and faster as the first step of reduction planning. So I couldn't do anything for collection of activity data for other urban areas, but one thing that I could do was to provide the emission factors, because in each methodology, in each sector, we do have emission factors, and I try to collect some tables including emission factors that they are not only collected based on different units, but also based on different source of fuels and locations. So that it can help other estimators to figure out the suitable emission factor in these tables. So here we can see the information for urban public transportation is provided by STM, and it is based on the fuel consumption. We do have gasoline, diesel, natural gas, biodiesel, and hydropower, which is consumed by STM. And here, this is the emission factors for transportation. As I mentioned before, we do have based on different fuel types and units and locations. In this slide, you can see the energy consumption in Montreal in 2016 by STM, and you can see that diesel with 55% is the main source of fuel by urban public transportation in Montreal. And on your right side, you can see the greenhouse gas emissions in Montreal by fuel in 2016. That it shows that diesel 95% is the contributing rate of diesel to greenhouse gas emissions by urban public transportation. During my thesis, I tried to figure out the trends also of greenhouse gas emissions from different sources of fuels in different sectors to figure out what are the trends of greenhouse gas emissions over, for example, 10 years or even more. So here you can see the greenhouse gas emissions from diesel over the 10 period. This is a result. This is beginning from 2006 to 2016, and on your right side you can see the greenhouse gas emissions from electricity. Here you can see also the biodiesel and gasoline. And for suburban public transportation, let's say there are 6 lines of suburban public transportation that they connect urban area Montreal to the suburb. So this methodology is based on the amount of actually the distance that they travel. So you can see EXO 6 because it travels the highest distance, so that's why it has the greatest amount of greenhouse gas emissions. So for private vehicles, we do have 3 different categories like light, medium, and heavy vehicles. So, and they are defined by the weight of vehicles. So at the bottom of this slide, you can see the number of vehicles registered in 2016. And this is the road transportation emission factor that they are provided based on different vehicle types, different source of fuels, units, and locations. Here, I wanted to compare the greenhouse gas emissions from heavy vehicles and light vehicles. And you can see in Montreal, heavy vehicles are producing the higher, actually the highest amount of greenhouse gas emissions. And now this table, actually this table is very valuable for me because it exactly took 1 year to get it from Energy. I dropped by their office several times and I emailed them, I called them, and eventually I got this information, which is only for Montreal, because you know there are a lot of annual reports by Hydro-Québec, by Énergie, and even for Ville de Montréal that they belong to the Great Montreal. But because I just wanted to assess the greenhouse gas emissions from Montreal Island, so that's why I had to try more to get the information only for my urban area. So. And here the emission factors for natural gas, and on your left side you can see the natural gas consumption by its sector in 2016, and industry part with 39% is the highest amount of natural gas consumption, and also as the second part we do have commercial with 25%. On your right side, you can see the greenhouse gas emissions from natural gas over the period from 2014 to 2017. And although industry, the greenhouse gas emissions from industry is increasing slightly, the residential part and the residential and institutional are stayed stable over the same period. But Energy believe that they could save over 13 million cubic meter of natural gas by energy efficiency programs in 2017 and 2018. On your right side, you can see the greenhouse gas emissions from natural gas, but because during my presentation and collaboration with Ville de Montréal, the question that is raised up by the city, it was what is the greenhouse gas emissions per capita? It was really important for them to know what is the contributing rate of individual person. So that's why in my old graphs, I try to figure out the total greenhouse gas emissions and greenhouse gas emissions per capita as well. So as you can see here, when we compare Montreal with London and New York, although the total greenhouse gas emissions of New York has the highest level, the greenhouse gas per capita for Montreal has the highest level. So for electricity, actually, I think we have to know that electricity in Montreal is generated by different sources of fuels, and 99% of electricity is generated by hydropower, and only 1% is generated by thermal power, like diesel, gasoline, and such thermal power. So, and the emission factors for operation of electricity generated by hydropower is zero. So that's why we do not have any greenhouse gas emissions from electricity generated by hydropower in 2016. But yes, for the life cycle, definitely we do have greenhouse gas emissions from electricity generated by hydropower. So this is the emission factors for electricity sources, and this is the comparison of greenhouse gas emissions from electricity generated by thermal power based on different sectors, the residential and commercial, and definitely residential has the higher amount of greenhouse gas emissions. For the solid waste disposal, I try to compare Montreal with other cities, and that we can see that Montreal has the highest greenhouse gas emissions, the total greenhouse gas emissions, and greenhouse gas emissions per capita as well. So, and here you can see the trend of greenhouse gas emissions from municipal solid waste disposal over the trend of 2015-2018, and you can see that this is decreasing moderately, and this is a very good achievement for the Ville de Montreal. So, and wastewater treatment. First, I'm going to show you the amount of treated wastewater, and then I will go for the comparison of greenhouse gas emissions over Canadian cities. So you can see that Montreal has the highest level of treated wastewater, total treated wastewater, and wastewater treated per capita. And it's not so far because the city believes that Montreal, among other Canadian cities, has the highest level of production of water. So it's not so far that they also have the highest amount of treated wastewater. And because the methodology is based on the amount of wastewater, so that's why we can see that the greenhouse gas emissions by wastewater, the highest amount belongs to Montreal. And here you can see the ratio of total greenhouse gas emissions from Montreal in 2016. Let's say private vehicles with 52% of total greenhouse gas emissions has actually is the largest driver of greenhouse gas emissions, and also natural gas with 26% is the second largest driver of greenhouse gas emissions. And then we do have solid waste disposal with 9%, 8% actually belongs to wastewater treatment that has the highest highest level of greenhouse gas emissions. And although only 1% of electricity is generated by thermal power, 2% of total greenhouse gas in Montreal belongs to electricity. And this is the comparison of greenhouse gas emissions from different cities. Now we can see the comparison of New York, London with Montreal and other urban areas. But to have the net greenhouse gas emissions, we have to consider carbon sequestration by urban green space in urban areas. So for this part, I developed a methodology based on number of trees, which is multiplied by the fraction, the absorption factor. At the end, I can say around 10 ton carbon dioxide equivalent is sequestrated by trees and green space in Montreal. So at the end, I can say when we subtract the carbon sequestration of the total greenhouse gas emissions, we can say the around 13 million ton carbon dioxide equivalent is produced in 2016 in Montreal Island. So the sensitivity analysis is done in my work, and we don't have this part for other studies for urban greenhouse emissions. So in sensitivity analysis, we try to figure out which factor has the most impact on the total greenhouse gas emissions. And because I had different factors, I tried to divide them into two sectors: emission factors and other factors. Emission factors that include any emission factors that they are used in my assessment, and other factors includes other factors like degradable organic carbon, average travel distance, total travel distance, average weight of trains, and so on. So when we run the sensitivity analysis for emission factors, we can figure out the most significant emission factor is emission factor for heavy vehicles, and then emission factor for methane in wastewater has the highest second level, and the third significant emission factor is the emission factor for light vehicles. At the bottom of this slide, you can see here in the graph of main effects plot for response, emission factor for heavy vehicles has the most variation. The most significant factor is the average travel distance for light vehicles, and the third significant factor is degradable organic carbon. For the next step, we can improve the analysis, because during my thesis, I tried to get the information, but it wasn't really successful. But in further studies, we can focus on those two sources because they're considerable greenhouse gas emissions. And I'm always thinking about develop an urban greenhouse gas emission software as the first step of reduction planning, faster and easier. And thank you so much to those organizations that they helped me to provide the information, and we did have some collaboration. And thank you so much.